Step 1. Prepare the needed ingredients. Step 2. Slice the ingredients into small pieces. Step 3. Peel the papaya as the main ingredient. Step 4. Shred the papaya. Step 5. Cook the ingredients in the boiling vinegar. Step 6. Mix the solutions and the ingredients. Finished product.
Atsara is a pickle made from grated and ripe papaya that is often served for fried or grilled foods. Now, the main ingredient here is the grated and ripe papaya and of course the vinegar, which the vinegar itself has a made impact or effects on why it has a colligative property, which identifies us that it has an osmotic pressure. Now, what is an osmotic pressure? Osmotic pressure is when a semi-permeable membrane separates a solution from pure water, and osmotic pressure must be supplied to the solution side to the limit fluid movement. Now, this concludes and identifies us that because of the vinegar has a high acidic acid, the bacteria and microorganisms can reduce right away. Why? This is because any food that can be preserved by the use of vinegar, it will minimize it from getting rotten. Thus, the vinegar has a lower pH value. This means that the atsara, or since the papaya is immersed on a vinegar, it has the high concentration of solute that in the pickling solutions inhibits the growth of the bacteria, which concludes us why there is an osmotic pressure in this preserved food. And that's all. Now, here is my partner to discuss another colligative property that can be also seen here in atsara. Partner?
Thank you for introducing the properties of atsara, my partner. One of those colligative property that we can observe was the vapor pressure and the boiling point. Okay, as we can observe here, when it comes to a pure solvents such as water, the vapor pressure is higher than when it comes to non-volatile liquid solution. This is a reduced vapor pressure results in a higher boiling point. When a solute is present in a solvent, the vapor pressure is lowered because a fewer solvent molecules are present at the top of the solution. Since vinegar is a solute, the amount of vapor pressure lowering depends on the amount of solute particles in the case. In the case, the vinegar decreases the ability of evaporate because it is a solute. And on the other hand, vinegar affects the boiling point, which because the pressure of the solute particles decrease the vapor pressure of the liquid solvent, a higher temperature is needed to reach the boiling point. Thus, the greater the concentration of the solute, the more it raises the boiling point. Watch this for more information.
prepare the ingredients and the instruments that you'll need. In a medium mixing bowl, empty the 2 all-purpose cream or heavy cream. After that, mix it with a hand mixer, or you may whisk it manually until the consistency is slightly thick and creamy. And then add the condensed milk to the bowl and combine it well. Fifth step, separate the white filling and the biscuit of cream oat. Crush the cream OS and fudgy bar to make it into small chunks. After that, set aside a small portion of your crushed cream OS and fudgy bar to add it as toppings of the ice cream. And then combine the cream and the crushed cream OS and fudgy bars in the bowl. And then, transfer it to a container or a Tupperware. Add the topping that you saved a while ago. And the last and final step, place it in the freezer and wait until it's frozen.
So now let's get our ice cream. Wow.
Enjoy your ice cream.
So hi, we are here to discuss the colligative properties we can observe in making ice cream. We all know that we need to release the heat to change the phase from liquid to solid. This phase change can be observed when making ice cream. One of the colligative properties we can observe is the freezing point depression. Freezing point depression is the phenomena that describes why adding a solute to a solvent results in the lowering of the freezing point of the solvent. The best example is the salt and ice combination. The salt helps the ice to get colder and makes the ice freeze faster. To freeze the ice cream mixture, we need to put the mixture in a colder location. The ice cream mixture will release its heat and absorb the energy or coldness of the ice or freezer. It will start getting hotter when its temperature reaches the freezing point.
I don't wanna see you crying anymore. I just wanna be the reason you can smile to.
Yo! As we observe on a daily basis, even during our childhood, but I'm not sure if I'm the only one who experienced this, but I always do this when I was a child. And we tried to check if the lights were closed inside the refrigerator. Or just simply stand by there, especially when the weather is hot, you know. We'll notice that there is a smoke or vapor that's coming out of it. But this does not only happen inside the refrigerator, but also in other substances. Other cold substances or things such as ice, frozen meats, and fish, and also, of course, to the ice cream that we make. However, smoke is defined as a visible suspension of particles in the air, generally released by a burning material. Therefore, a cold substance cannot emit smoke. So what about the dry ice? Well, dry ice is a different situation from what we are talking about right now, since it includes different substances such as carbon dioxide and a specific temperature. So, what are these gases that we are seeing? Well, those were not actually gases, but probably water vapor or steam in the air condensing around the colder air surrounding the cold ice cream container. So what is vapor and steam ba? Well, vapor is the liquid water that dissolved in the air, while the steam is the water in gaseous form. So it is actually a liquid in a gaseous form. This happens because of the sudden encounter of the ice-cold surface surrounding the container that rapidly cools the warm water vapor in the air outside the freezer, which makes the vapor to condense around the particles of smoke in the container. For this reason, of an increase in temperature or sudden hot of the surrounding of the ice cream's container, the kinetic energy of the molecules also increases, which makes the number of molecules transitioning into vapor increase, thereby increasing the vapor pressure surrounding the ice cream. Did you get that? So, as you can see, there are tiny drops of liquid water in our ice cream container. air. This is basically because the water vapor molecules slowed down and joined together and has turned into tiny drops of liquid water.
So, next, the melting point. As the surrounding of the ice cream meets the room temperature, the ice cream absorbs the energy or heat, making the molecules of the ice cream begin to vibrate, and causes the orderly arrangement of molecules to collapse and move past and get closer to each other. For this reason, the ice cream will start to melt slowly, and the ice cream will then return into a liquid once again when it reaches the melting point. But did you know, freezing occurs at the same temperature as melting? Hence, the melting point and freezing point of a substance are the same temperature.
Just a little time, just a little something that I need.
So, as what my partner and me discussed a while ago, we can therefore conclude that the relationship between the freezing point, melting point, and the vapor pressure are directly proportional. This means that if the substance freezing point is high, its melting point is also high, and its vapor pressure is also high. Thank you.
First, prepare the materials that you'll need in making the pineapple jam. After that, chop and slice the ingredients.
Just a little
And then, boil the pineapple in a pan.
just a little something,
Add the sugar and mix it until it caramelized.
just a little time, just a little time.
Pineapple jam is a simple process of food preservation that includes pineapple, all-purpose sugar, and lemon. But since lemon isn't available, we substitute it with calamansi, where we can find in our own kitchen. In this process, fresh or pre-cooked pineapple is boiled with all-purpose sugar with 1:1 ratio. Because too much pineapple and you may lose the sugar preserving effects, and too much sugar may crystallize during storage. And because this is homemade, it's not fitting to use artificial pectin since pineapple contains a small portion of this enzyme, and it will be apparent in the process. If you are asking what pectins are, it's long linked chains of sugar molecules found naturally in plant cell walls. And this played a vital role in jam making as it suspends the pieces of fruit binding to each other via intermolecular interactions, forming a gel-like network. And boiling the jam releases the pectins from the fruit used with the correct amount of sugar and acidity. And as we've read, the colligative properties are quantify-dependent properties that depend on the ratio of the number of moles of solute particles to moles of solvent particles. We can conclude that the apparent colligative properties in jam making process is 1. Boiling point elevation, because the more solute or sugar we put in the process of jam making, it is most likely to increase the boiling point of the solution, which means that our solution isn't going to boil in 100 degrees Celsius and boil higher depending how much sugar we put in the solution. On that note, we can see the causal relationship between this solution. The more solute in the solution, the higher the boiling point elevation. And while boiling, it aims to evaporate that required water quantity to expedite the formation of pectin sugar acid gel in the pineapple and partially convert sugar into caramelized paste, which is from solid to liquid. And liquid at a high temperature has tendency to evaporate. Since evaporation process is apparent, in this process, we can conclude that the greater temperature of the liquid, that the average kinetic energy of the molecules in the liquid. The greater the kinetic energy, the greater the evaporation rate, and the greater the vapor pressure. Therefore, the higher the temperature, the greater the vapor.